In this class, we are going to demonstrate an experiment to determine focal length of a concave mirror. Here we have a concave mirror. We are going to describe an experiment to determine its focal length. We have a screen here. We have our mirror holder. We have an illuminated object. The wire mesh here is going to act as our object. When we switch on the light will illuminate that wire mesh, and that wire mesh will act as our object. So there we go. That is our illuminated object. We shall put the concave mirror in the mirror holder, and we shall place it at a distance of 15 centimeters. We are going to use an object distance of 15 centimeters from the object. So this is our object distance from the mirror to the object is 15 centimeters. So we shall switch on the light so that we have our illuminated object ready. Then we move this screen in front of the mirror in order to locate the image. Okay. So we move the screen until we get the sharpest image possible of the wire gauze. So there we have a sharp image of the wire gauze on the screen. So next we measure the image distance, which is the distance from the screen to the mirror. The distance from the screen to the mirror is 30 centimeters. The distance from the screen to the mirror is 30 centimeters. So from our experiment, we had an object distance U of 15 centimeters. When we got the sharp image, the distance between the screen and the mirror, V, which we call the image distance, was 30 centimeters. So using the mirror equation, 1 over U plus 1 over V is equal to 1 over F. We shall have 1 over F is 1 over 15 plus 1 over 30. So we get our focal length as 10 centimeters when we solve that equation. Therefore, the focal length of that concave mirror that we used is 10 centimeters. In this experiment, we are going to demonstrate how the focal length of a convex lens can be determined using an illuminated object and a plane mirror. So we have our illuminated object. We are going to use this wire gauze as the illuminated object. When we switch on the light, the wire gauze is illuminated, and this is going to act as our object. We have a lens holder. We shall put our lens in the holder, and we shall place the mirror behind. And then just at the same position, at the same distance as the object, we shall put the screen in order to receive the image. We move the lens mirror combination until we get a sharp image of the illuminated object on the screen. You see, when we move it, it becomes unclear at that point, but as you move it closer, it becomes clearer, and then it loses focus. So we are looking for a clear image of the wire gauze on the screen. The screen is the same distance as the object from the lens. So when that happens, it means that the distance between the lens and the screen and object is equal to the focal length of the lens. So we are going to measure that distance, okay, the distance. And as we can see, the distance between that object and the lens is 10 centimeters. And that means the focal length of that lens is 10 centimeters.